Good day, viewers. Another question on trig identities. We are asked to prove that sec 8a minus 1 over sec 4a minus 1 is equals tan 8a over tan 2a. Okay, now remember, when it comes to proof, okay, like this, okay, we need to understand that the left hand side is equivalent to the what? Right hand side. So which means we can start from the left hand side. Okay, we can use the left hand side to prove the right hand side, or use the right hand side to prove the what? Left hand side. It depends on the way the question is given. All right, so but let's look at it this way. Now, to be able to prove this identity, okay, we are given sec 8a minus 1 over sec 4a minus 1 equals to tan 8a over tan 2a. So let's write LHS, okay, equals to RHS to establish that the left hand side is equal to the what? To the right hand side. But we are using the left hand side, to prove this guy on the right hand side. So I'll then write left hand side is equals to sec 8a minus 1 over sec 4a minus 1. Okay, now to be able to prove that this identity is equal to this other one on the right hand side, now we need to understand that when we have sec, that's secant of an angle, okay, that will be what? The reciprocal of cosine, that's cosine, that's cos. Okay, so sec is equals to the reciprocal of cos. So let's write sec 8a and sec 4a in terms of cosine. Okay, now step 1, okay, step number 1, okay, write sec 8a and sec 4a, okay, in terms of cos, okay, that's cosine. Let's put it that way. So that means that we know that sec 8a, okay, sec 8a will be reciprocal of cos 8a. Okay, now sec 4a is equals to the reciprocal of what? Cos 4a. Okay, so we're going to what? We're going to substitute these two identities into the one we have here. So let's put it this way, substituting these identities into the expression above. The expression is this expression. So we know that sec 8a minus 1 over sec 4a minus 1 will now be equals to, okay, implies that we have 1 that is reciprocal of cos 8a minus 1 all over reciprocal of cos 4a minus 1. Now let's simplify this expression. So we can see that this is we have 1 over cos 8a, okay, minus, that is, it will be 1 minus cos 8a over cos 8a, okay, divide by 1 minus cos 4a over cos 4a. Now we can simplify. Now this is the numerator and this is the what? Denominator. So when we divide two fractions, the one which is under will flip, okay, when the division bar is changed into what? Multiplication. So we can write this as 1 minus cos 8a over cos 8a multiplied by cos 4a over 1 minus cos 4a. Okay, now that we have 1 minus cos 8a over cos 8a multiplied by cos 4a over 1 minus cos 4a. Now let's do some trick here, okay? Now let's see let's apply one of the identities, to be able to, to write this in terms of sign. That is 1 minus cos 8a and 1 minus cos 4a in terms of what? Sign. Okay, so we're going to use the we're going to use the double angle identity. So now using the double angle identity, okay, we know that when we write cos square theta, let's say cos square a, rather, okay, minus sine square a, okay, which is equals to cos 2 or 2a. That is same thing as 1 minus what? 1 minus 2 sine square a. 1 minus 2 sine square a. Okay, so in this case, we have 1 minus cos 8a. Okay, now this is, of course, this is cos 2a. So if I move this outside and I'll move this in, it's going to become 1 minus cos 2a will be equals to 2 sine square a. So which means in this case, if I write cos square, that is, I'm going to write cos 8a, okay, cos 8a will be equals to 1 minus 2 sine square 4a. Okay, 1 minus 2 sine square 4a. That's a logic. So which means similarly, so for cos 4a, it will be cos 4a will be equals to 1 minus 2 sine square 2a. Okay, that is if you understand the double angle identity. Okay, for cos 2a is cos square a minus sine square a, and the same thing as 1 minus 2 sine square a, or we can also have it as 2 cos square a minus 1. But in this case, because we have cos 8a, so using that double angle identity, then it means cos 8a will be 1 negative 2 sine square 4a. Then for cos 4a, it will be 1 minus 2 sine square 2a. All right. So we're going to, so in this case, now let's rearrange each of these, identity, so that we can have something like this. So which means from here, okay, this will become cos 8a. Okay, when this is moved down here, we have 1 minus cos 8a. Okay, 1 minus cos 8a, 1 minus cos 8a. That's when this comes here and we move this down here, okay, to the left hand side. Then that will be equals to 2 sine square 4a. Then the same thing, this will be 1 minus cos 4a will be equals to 2 sine square 2a. Okay, so which means 1 minus cos 8a is equals to 2 sine square 4a. Then 1 minus cos 4a is equals to 2 sine square 2a. So we can now substitute this for 1 minus cos 8a and 1 minus cos 4a. Now substituting, okay, 2 sine square 4a, okay, for cos 8a, for 1 minus cos 8a, okay, and 2 sine square 2a for 1 minus cos 4a. Okay, so which means this will now be replaced with what? 2 sine square 4a, and this will be replaced with what? 2 sine square 2a. Now let's rewrite that. So we know that 1 minus cos 8a, okay, over cos 8a multiplied by cos 4a over 1 minus cos 4a can now be written as, so this will be 2 sine square 4a over cos 8a, then multiply by cos 4a over, this will be 2 sine square 2a. That's it. So now when we talk about, when we have 2, that's 2 sine square 4a. Sine square 4a is the same thing as sine, that's sine 4a multiplied by sine 4a. So I can write this as 2 sine 4a multiplied by sine 4a. Okay, then we also have multiplied by cos 4a all over. Then we have cos 8a multiplied by 2 sine 2a. Okay, sine 2a. Okay, let me also expand that. Okay, now now it is also important to note that cos 8, sorry, sine 2 sine 8a, okay, using the double angle identity, okay, is the same as 2 sine 4a, okay, cos 4a, okay, cos 8a is the same, sine 8a rather is equals to 2 sine 4a cos 4a. So we have sine 8a equals to 2 sine 4a cos 4a. Okay, also let's say we want to write that of sine 4a. Okay, that will be 2 sine 2a, okay, cos 2a. Okay, that's how it is. Okay, now, so which means we're going to what? We're going to combine. That's when we combine 2 sine 4a and cos 4a. That will be what? That will be equals to sine 8a. So we can say that in the numerator we can rewrite that to be 2 sine 4a cos 4a. Remember, we have sine 4a, sine 4a. So this is in bracket. Then we now have sine 4a all over. Now, the denominator, we have cos 8a. So there is cos 8a in the denominator. Then we also have 2 sine 2a sine 2a. Okay, so now we can see here that 2 sine 4a cos 4a will now be equals to sine 8a. So we can say that this will be sine 8a, this guy, multiplied by sine 4a over cos 8a, multiplied by 2 sine 2a, okay, because remember we have 2 sine square 2a, and sine square 2a will be sine 2a sine 2a. So this will be sine 2a. All right, so now, then also for sine 4a, that will be 2 sine 2a cos 2a. So let me write the expanded form of this. So this will be, the identity for this will be, we have sine 8a, okay, over cos 8a multiplied by, so for sine 4a, that will be 2 sine 2a cos 2a over 2 sine 2a, okay, sine 2a. So sine 2 sine 2a will cancel out. So we'll be left with what? So we then have sine 8a over cos what? Cos 8a multiplied by cos 2a over sine 2a. Now let's not forget that sine 8a over cos 8a will be equals to tan 8a, okay? Then also cos 2a over sine 2a, that will be equals to tan 2a. That is, sorry, cot 2a. Cos 2a over sine 2a, that will be cot 2a, which is same thing as what? Reciprocal of tan 2a. Okay, so which means cos 2a over sine 2a, this guy is reciprocal of tan 2a. Then sine 8a over cos 8a is what? Tan 8a. So we then have this will now be tan, that is, we have sine 8a over cos 8a multiplied by, so we then have cos 2a over what? Sine 2a, okay, to be equals to, this will be equals to tan 8a, this guy, this will be tan 8a multiplied by reciprocal of tan 2a, and that will be equals to, so tan 8a times 1, that will be tan 8a over tan 2a. So we just proved that the left hand side is equivalent to the what? To the right hand side, because this is the right hand side, okay, that which is what we have here. So we just proved that sec 8a minus 1 over sec 4a minus 1 is equals to tan 8a over tan 2a. And we've come to the end of this session. The noblest pleasure is the joy of understanding. Bye-bye.